This video focuses on training convolutional neural networks (CNN) to classify X-ray images as showing or not showing signs of pneumonia. In this video, I'll walk you through the process of training a CNN using Python programming language and the Keras library. I will also show you how to run the project using the code provided. Pneumonia is a common and potentially life-threatening condition that requires prompt diagnosis and treatment. X-ray images are often used to diagnose pneumonia, but the interpretation of these images can be challenging. In this project, we trained a CNN to classify X-ray images as showing or not showing signs of pneumonia, with the goal of assisting radiologists in the diagnosis of pneumonia. To train our CNN model, we used a dataset of X-ray images that were labeled as normal and bacterial pneumonia. As you can see here, test, normal, and pneumonia. And here are the training dataset for normal and pneumonia. And they were split into 70%, 15%, and 15% respectively, with test, train, and validation. So 70% being the training data, 15% being the testing data, and another 15% being the validation data, approximately. We then defined our CNN model using the Keras library. Our model consisted of several convolutional layers and dropout layers to prevent overfitting. We also included several fully connected layers and a final output layer with a sigmoid activation function to produce a binary classification. We trained our model using the training set and validated it using the validation set. We used the binary cross entropy loss function and the RMS prop optimizer to minimize the loss. We also used early stopping to prevent overfitting and reduce training time. We trained with two different formats. One, we saved our model with .h5 format and one with .pickle to test out the difference in their accuracy for our testing data. For some instances, the .h5 format proved better, while in other instances, the .pickle format proved better. It mostly depended on the severity of the pneumonia in many of the X-rays. After training our model, we evaluated its performance using several performance metrics, including accuracy and precision. So to run the project, we need to go to the app.py file. I've also created a README file here with the link to the dataset and the instructions to install the dependencies and also to run the app.py file. So to run the project, we go to the app.py file, but before that, after training our model and saving it in our project by .h5 and .pickle, we can test it out in the predict section. And we can test our model here. We just have to change this, for example, ERR, and run it. So it's gonna load the model and open a small GUI here. And when we close the image, this is the training of the model that we did before. So after we close the prompt, it will show you the result that X-ray shows no signs of pneumonia. And this was just the predict.py file to test our model. The real project is in the app.py file, and we can run it using the command. We're just going to open terminal here and type streamlit run app.py, and it's going to open the browser here. It's going to load and it's going to give us an option to input our images, which we can do from here. Just go to my project file, X-ray samples. I'll just use some training, and you can select multiple images. After a while, it will show you the result. So these were normal images of normal X-rays, and 3 out of 4 of them were accurate to saying showing no signs of pneumonia. In conclusion, we trained a CNN model to classify X-ray images as showing or not showing signs of pneumonia. Our model achieved good performance and has the potential to be used as a tool to assist radiologists in the diagnosis of pneumonia in the future. Some of the training matrices are here as we were training the model. By following the steps I mentioned, you can train and evaluate your own CNN model for classifying X-ray images. We just have to follow the README instructions.